Hello and welcome to this short video presentation on GLOBEClaritas V7-3-1, which was released in August 2021. I'll go through some of the highlights of this latest stable release, and I will start with the new Tomo 3D application, which is a tomographic refraction velocity and statics modeling package. You can find the Tomo 3D application on the Statics tab of the Claritas launcher and marked Tomo 3D. So if I click on this, it will bring the launcher up, or bring up the Tomo 3D application. So it starts with a very simple interface where we load in the geometry, velocity and first break pics. So if I click on the geometry button and select a suitable geometry, it brings up a display showing the survey topography. If I then add a velocity, I can either read in a segy velocity grid file, a Claritas NMO file, or a previously saved velocities from the application, which are the GCV files. In this case, I will just read in a simple velocity field from Claritas NMO. So the little red dots are the velocity locations, the velocity information. I then add in the pics. We'll open those up and then display the receivers and sources in there and the pics that we've got for this data set. You can zoom in and out using the middle mouse button or wheel on your mouse. That's good. We can also turn the layers off, so if I click on the layers button, I can remove the velocity and the final pics and just display the topography, or I can turn those back on if I want to have them displayed. Then you can see up here there's a whole bunch of other tabs, a model, iterate, results and statics tab. So these are ways I can interact with how the model or the refraction tomography works. So the model allows me to define the resolution of the velocity grid that it's going to create as it generates the refraction velocity model, and that's in meters. Our highest elevation and the bottom of the model where we're going to sort of model down to, and then the origin of the survey. The iterate tab allows us to control the iterations as we go through a model refraction velocity and run the tomography. So we have two ways of running. We can run and manually control the information, the smoothness, weighting, etc. ourselves. Use the start button and it will run a set of iterations up to 100 iterations per run. And then we can change the parameters and start again, or we can allow the application to manage everything itself to try and optimize down to a perfect solution, if you like, and just click on the auto button and let it run away happily on its own. So basically the application uses hyperthreading. So if you're running on a machine with say 8 cores and can hyperthread up to 16 cores, it will basically manage itself and use as many cores threads that are available to optimize the processing time. If I get rid of that and open one I've previously run, so that's again, we're still on the iterate panel, and so we've got some diagnostics, so we can see that it's basically completed running through that one iteration that I set off. That's 94% complete because it only needed 94 iterations to get down to the termination tolerance that we'd set. So we have some QC panels down here, which include sort of weighted RMS, normalized MAD, and a display of the pic cloud. Once we've run an iteration, we can go to the results tab and it will show you the velocity model that's been generated. So we can display X, Y, Z, or inline crossline displays, and we can tab through these or slice through the depth slices to QC the velocity model that's been created. Similarly, we can step through the slices horizontally along the survey. And at any point during this process, as we run through the iterations, just to be safe, we can save out a velocity file, a velocity grid, so that we can come back to it later, or if we want to have, so we can save the velocity file out, and so long as it's in a grid format that we can then read back in, so we could go in and change the model resolution and make it finer or a denser velocity grid, etc. And also similarly, once we've finished developing a velocity model, we can basically write out a static correction into the seismic trace header. So what we do is we select a suitable HDF5 file, load that in, and we can see that it's showing all the shots and receivers on the HDF5 file, and then we can choose how far, what depth in meters we want to correct to. I'm going to say 500 in this case. We have a replacement velocity, so i.e. to replace where we've got no rock or anything, i.e. air, through the topography of 3000 meters, so you can put in whatever is a suitable replacement velocity for your data. And then we have the choice of either correcting for the local refraction variations along the line within a shot, or we can also apply a datum correction at the same time by just ticking off the correct datum button. We change it to just be localized small refraction static corrections. If we put the correct datum, then it will effectively correct to the datum elevation. And then if we click on the right button, it will then write out into the rec_static, source_static, and total_static trace headers the relevant statics calculated from this application. And then you can use the static module to apply those static shifts to your seismic data. So I will just bring up a job flow that does that. Put an AGC on it just so it's a little easier to see what's going on. I will just zoom in around a particular area and click all panels. Put that down in the middle of the screen there, and then if I toggle, I do sync panels as well. If I toggle that there, you can see where it's correcting the traces with the static that's been calculated by the Tomo 3D application. So the Tomo 3D application sits alongside our existing RefStat 3D application, so you'll have access to both methods for refraction statics analysis. So if it's a way you can QC and see which gives you the best result and pick the optimal solution for your data set, as RefStat 3D might work on some data better than Tomo 3D does, and vice versa. Tomo 3D may work on other sets of data better than RefStat 3D. So that's Tomo 3D. One of the other applications or new applications I want to talk about in this video is the ViewStatics application. Now, we've had a short video about ViewStatics previously, but I'll just refresh your knowledge or understanding of it. So ViewStatics can be accessed from both the SizeCat application, or again, if we go to the Statics tab of the launcher, there's a button on there that says ViewStatics. So if we're going to run it from the Statics application, basically what we would do is highlight, or from SizeCat application, so we'd highlight the shift files we want to view and select View Static Shifts brackets ViewStatics. If it's not got information in the header about geometry database associated with the shift files, it'll ask you to define one. So we'll just select PC9608 Geom. We're not going to update, in this case, the timestamps in there. And there you go. So what we end up with is a map view of the static shifts, a standard red-blue color map, and we can basically flip along the different things to have a look at the different resulting models. We can click on the XD display to display the static shifts in an XT style display, where we've got the blue dots are the receiver pegs and the red dots are the source pegs, the source statics. And again, we can compare those against each other. I'll do the same from the ViewStatics on the launcher. And again, if I highlight in the selection pane the statics I want to look at, and again we can toggle between the different models or shift files we're looking at. If we again click on the XT display, it brings up that panel, and in this case we also have a next and previous button to be able to tab through the receiver lines in these different files. So what the display shows is the solid blue lines of the receivers on this receiver line. The red dots are the nearest sources or shots to this receiver line, and then dotted lines are the adjacent receiver lines. We can scale or add a shift file by user-defined values. We can different shift files. So if I click OK, you'll see the XT display goes away, but will come back up once it's finished the differencing, and adds a panel down there and adds a panel to the tabs up here. We can sum different files together, or we can merge. So if we've had to run say residual or refraction statics in swaths on different bits of data, then we can merge those resulting shift files together using this application. So it's a nice, simple, clean interface, gives you a good map display. We can display 3D surveys, 2D lines and multiple 2D lines in the application, so we can compare adjacent or intersecting 2D lines in here. So it gives us a good processing or QC capability for statics files. It can display both refraction and residual statics based on source and receiver locations, as well as CDP elevation statics in here as well. That's all I want to say about ViewStatics at the moment. And finally, what I'll do is go to the geometry tab, and we've had some improvements to the geometry application. So again, from size cat, I can basically go into here, click on view geometry. It'll open the geometry up, and as you can hopefully see, we've got basically the source and receiver pegs displayed in blue, or receivers in blue, source pegs in red. We now have the capability in here to display shots or receivers independently. So if I turn off the shot display, it'll just show me the receiver pegs. Again, I can go back in, turn off receivers, turn shots back on, and display only the source peg locations. Or I can go back and display it in the similar way as it used to show in Claritas, in terms of all pegs displayed in a single green color, like that, if that's what you desire. So being able to split up between the source and receiver pegs has allowed us in the background to better understand whether a peg is for sources or receivers, or for both. And that means that when we now use the utilities, write new SPS files, it correctly writes out only the receiver information into the receiver SPS file, and only source information into the source SPS file. Previously, because the geometry application didn't necessarily differentiate between source and receiver pegs, when you looked at the R files that we created from the geometry application, they would have also the source peg information in there as well. That's been improved in this latest release. What I will also say is we also now have a receiver information button, so it'll basically allow us to display information about particular receiver pegs and the shots that are shooting into that receiver peg. So we get the shot values that are going into there, and we can tab up and down for there, as well as the as we previously had the shot information one, which shows us all the receiver pegs, etc. So just a little bit of added additional functionality. And again, like that, if we click on a receiver, then it shows the sources that were firing into that receiver along the line. So yeah, that's the improvement to geometry. In terms of other improvements to the software in this release, we have a new redataming solution for 2D data sets. Uses Kirchhoff imaging technology to redatum the sources and receivers to the datum of your choice. We have new tools to aid first break picking and QC, a new initial pick method for automated picking within the SV application, which gives a more robust initial pick, and therefore make sure that your secondary pick methods hone in quicker and better into the actual first break pick. And then there's a new calc pick module to assist QC as well. Size read can now read past corrupted portions of data, allowing for recovery of data if required. So if you've had a disk crash or some other situation occur with a data set that you can't read it, the size read should now be able to read past those problems and allow you to recover data from corrupted files. And SizeCat now allows you to launch 3D grid files from within the SizeCat application. So again, if I go to SizeCat and then click on a grid file and say display 3D grid, you can see it brings up the 3D grid file, so you can do some QCs around how effective the grid is, check some coordinate information, make sure it converts it to the correct inline crossline, etc. So that's everything. That's the key new features in the V7-3-1 release. We look forward to your feedback when you start to get using these new applications, and any questions, please do contact support@globeclaritas.com. Thank you for your time and goodbye.